Here we go. So, function operations and compositions. You guys have actually done this before in Algebra 2, okay? You actually did this towards the very beginning. So some of this is going to be reviewed. But the part that's going to make it a little bit pre-calc that we're going to find the domains of these composite functions and of these function operations, which honestly is not too hard. It is actually easy because you've been finding the domains of functions already. So here we go. Let f and g be two functions with intersecting domains. Then for all x values in the intersection, the sum, which means what? What's another word for sum? Addition, product, multiplication, difference, subtraction, and quotient, division are now functions that are defined as follows. You guys need to be able to recognize that when you see f plus g of x, you're literally just taking the f function and adding it to the g function. When you see f minus g of x, that means you're taking the f function and subtracting it from the g function. Be careful with that one because students tend to forget that you got to carry over the negative. F times g of x means you can take the f function and multiply it to the g function. And f divided by g of x means f of x divided by g of x. Realize that f times g of x written this way is the same thing as writing it just fg of x, okay? That means multiplying as well. So I don't want you to be too confused. So the first one, f plus g of x. That means we're going to take f, I'm going to add it to g, and simplify if I can. So f is x squared plus 4x. I'm going to add it to g, which is the square root of x plus 2. Can I combine any like terms? So that's that. That is the operation. If I could combine like terms, then I would, but that's as far as I would go after that. Now to find the domain. Is there anything that you recognize? You got kind of a mix of functions here. You got to take both of those mixes into consideration. I got a square root here. Can I take the square root of any number? What number could I not take the square root of? A negative number. So that means that x plus 2 has to be greater than or equal to 0. You guys remember that from section 1?
Yeah.
Hopefully you haven't forgotten. Whenever there's a square root, whatever's underneath the square root has to be greater than or equal to 0. You solve it out to get x is greater than or equal to what number? And there is your domain for this function. We need to write it though in the two ways. What are the two ways? Set and interval. You choose which way you want to write this one. I heard set. Remember, set is easy. Because when we solved this out, we got the meat of our set notation. X such that x is greater than or equal to -2, and x is an element of all real numbers. Very good. And that's it. That's the domain. So you can't forget anything that you learned back in section 1. You don't worry about it. What's the domain of a quadratic? Negative to infinity. So it technically it's all of them. You only got to worry about the part where it is restricted. Shop. Was that question? Let's look at B. I'm doing f minus h. So f minus all of h. You're subtracting all of h. So put it in parentheses. Because you mustn't forget to do what? Distribute the negative. So it's x squared plus 4x minus 3x plus 5. Can I combine like terms here?
Yes.
Sure can. It's going to be x squared plus x plus 5. That's it for the operation part. Now we just have to find the domain, which is super easy. Which makes it a what? A quadratic, which is what, Jamie? It was only a quadratic. There wasn't no square roots in there. There were no fractions. So the domain Negative infinity to infinity. Questions? FH, what am I doing here? So I'm going to multiply x squared plus 4x to 3x minus 5. I'm going to have to FOIL. Do it right now. 3x cubed is your first. Minus 5x squared is your outer. Plus 12x squared is your inner. Minus 20x is your last. I can combine like terms, yes?
Yeah.
So it's going to be 3x cubed plus 7x squared minus 20x. This is a cubic, and the domain for a cubic is negative infinity to infinity. And we're done with that one.
So cubic is the same thing as
Uh-huh. And technically, all but your square root functions and your reciprocal functions are all real numbers for the domain. So only those two have a domain that's not all real numbers. Last one, D. We're dividing H by F. No, I cannot cancel these x's. I can only cancel common factors. But what can't equal 0? The denominator. What were you saying?
I said, can't you? No.
So the denominator cannot be 0. So I set the denominator equals 0 and find out what value to make it 0. How do I do this? Factor out an x. Then I'll be left with x plus 4 on the inside. So then x is equal to, and x is equal to what other number? So that means that every number but 0 and 4, negative 4, the set will be so much easier. And it's right over there on the board for you guys. For those who are watching the video at home. There's your domain.
I know.
Skip it over those next couple of examples so you guys can do that on your own for more practice. A composite or composition is the result of one function being used to evaluate a second. This should look familiar. You might want to write this down if you forgot.
Oh, that's not on.
Fog, f of g of x, very different from that being a closed circle. If it was closed, it'd be multiplication. But this is composite. You put one function in for the other. How do you know which function? Whatever's at the end. That function goes in to the first function. This is usually a better way to see it. So we're going to do that for this example right here. F of g of x. That means g, which is x minus 4, is going to go in for every x of the f function. Does everybody see what I did right here in the pink? I just rewrote g of x as x minus 4. We did this back in the very first section when you were evaluating, so this should look familiar. Everywhere I see an x, I'm going to put an x minus 4 in F. Does everybody see that? I replace this x with x minus 4. Now I have to what? FOIL. So it's going to be x squared plus 16 plus 1. So x squared minus 8x plus 17. And what's the domain? Because this is a quadratic. Like you're gonna know? Sorry. The next one. This time, I'm putting F into G. So everywhere I see an X, I'm replacing with X squared plus 1. I got a minus 4 at the end. Don't forget about those, like extra pieces. Don't forget about those. So my answer is going to be X squared. And what's the domain of this? Negative infinity to infinity. Coming back to you guys with the composites.
Yeah.
And the domain part is what we did at the very beginning of this lesson, and then also back in section 1. Now see, you're actually evaluating a particular number. 2 ways you can do this. You can do the composite first, and then plug in 2. Or you can actually plug 2 into G, get an answer, and then plug that answer into F. Either way will get you the same answer. Okay? Now, considering we already did F of G of X, plug it in. Huh? No, you don't multiply by 2, you plug into. You plug into in these cases. And we're going to plug it into this function right here because that is what the composite is. Two squared is 8 times 6, 2, 16. And when you're evaluating to a particular number, you don't have to worry about domain and range. Okay? So you guys remember composites, right? I do apologize that I'm going fast on this, so I just want to make sure I get it in. So like I said, this is review from before. Now, one thing you do have to be aware of when you're doing domain with composite functions is the original input function. Listen to me here. If the original input function has a restriction on its domain, then you have to take that into consideration when you're finding the domain of the composite. Look at the next, not this set. Well, look at this example here, where f of x equals, look at this one, x squared minus 2, and g of x is the square root of x minus 3. Okay? We're trying to find the composite f of g of x. But g is a square root function, and those functions always have restrictions. It has to be greater than or equal to what number?
0.
So that means that x has to be greater than or equal to what? 3. So if I write that in integral notation, that's 3 to infinity. That's the domain of that g function. You have to take that into consideration once you find the domain of your composite function. Okay? So let's do the composite real quick. I'm going to plug in the square root of x minus 3 into f. Okay? So I have the square root of x minus 3 squared minus 2. Does everybody see that composite? What happens when you square a square root? So I have x minus 3 minus 2, and so you get, now x minus 5, that's a linear function, whose domain is what? Negative infinity to infinity. But because the original input function had a restriction, it's basically, you gotta look at both domains and see where they overlap. Because where they overlap, that is the domain. So it's just gonna be from 3 to infinity. Because the restriction on the original input function. That only applies for composites here. That only applies for composites. You gotta look at the original inputs domain. Okay? Questions? I'm doing the same thing, f of g of x. What's the domain of g? So I have no restriction here, do I? No, okay? So I'm gonna do my composite like I was doing before. And I'm gonna find the domain of that. And if there's a restriction on that, then that's my domain. So I plug in g. So it's gonna be 1 over x squared minus 9 plus 1.
Teachers, please pardon the interruption.
Bring it back. I told you I was going all the way. Here we go. Might finish up a little early. Here we go. You should have gotten x squared. What on the bottom? Minus 8. There's your composite. So then you have to figure out what's the domain here. I cannot have what? Where? In the bottom. So that means I have to set x squared minus 8 equal to 0 and solve. How do I solve this? Add 8. And then, and whenever I square root, you have to remember plus or minus. Can I simplify the square root of 8? 2 square root 2. So it's going to be all real numbers except positive and negative 2 square root of 2. Which way you want to write it? Probably the easiest way, because all you do is write in what you just found. And x is an element of all real numbers. Questions on domain of composite functions, especially when there's a restriction. I'm going to stop here and I'm going to do the last little bit on Monday after you guys take a quiz.